So let's take a look at some applications of the cross product. Remember that the cross product is written as A cross B, where A and B are any two non-collinear, non-zero vectors in 3-space. Since A cross B is a vector, it has both magnitude and direction. So the first application of the cross product relates to the calculation of the area of a parallelogram. So given the parallelogram shown here, notice I have two vectors A and B, drawn tail to tail, and the angle between those two vectors is theta. Recall that the area of a parallelogram is base times height. And in our example, the base of this parallelogram is the magnitude of A, and the height is labeled as h. So it's the magnitude of A times h. So let's take a look at this triangle here. We see that the sine of angle theta is equal to h over the magnitude of vector b, which tells us that h is equal to the magnitude of b sine theta. So if we replace the h here, we have that the area of this parallelogram is the magnitude of vector A, the magnitude of vector B, sine of the angle between vectors A and B. So this is the magnitude of the cross product for two geometric vectors, which happens to be the area of the parallelogram determined by two vectors A and B. So example 1, determine the area of the parallelogram formed by the following points, A, B, C, and D. To use the cross product to find the area, we need two vectors drawn tail to tail. So let's say we take these two vectors here, vector AB and vector AD. So if I want the area of this parallelogram, that's going to be equal to the magnitude of AB cross AD. So all we need to do is figure out the components of vector AB. So remember that's OB minus OA. Here's vector OB, and here's the components for vector OA. So OB minus OA is going to be equal to 0, -2, -1. And then we're going to cross that with vector AD. So there's D. So there would be the components for OD and OA. So OD minus OA would be equal to 4, -1, and 4. So next part, let's determine the cross product of AB minus AD. So we end up with -8 minus 1, so that's -9. We end up with -4 minus 0, so that's -4. And we end up with 0 minus -8, so that is +8. So there are the components of AB crossed with AD. And therefore the magnitude of this vector would be the square root of -9 squared plus -4 squared plus 8 squared. And this equals the square root of 161. So therefore the area of this parallelogram is this root of 161. The second application of the cross product relates to a concept in physics called torque. So the torque, or the turning effect, of the force F about a point M, so we're applying a force here around this pivot point M, is defined to be the vector R cross F. The force is measured in newtons and the distance, or the radius, is measured in meters. So the units of magnitude for torque is Newton meters, or just joules. So again, here is the value for R. So this would be considered vector R, and this would be considered vector F. And notice they both have a direction and magnitude. So a 20 Newton force is applied to the end of a wrench that is 40 centimeters in length. The force is applied at an angle of 60 degrees to the wrench. Calculate the magnitude of the torque. So let's draw a picture of this. So let's say here is our object. There's our wrench. We're told that the wrench is 40 centimeters in length, so starting from here and going outwards, we note that this has to be in meters, so that's 0.4 meters. And then there's a force being applied to the wrench at an angle of 60 degrees. So if we draw that here, it's being applied at an angle of 60. But remember, we need to arrange these tail to tail, so I'm going to move that over to here. And notice with the Z pattern that this is still 60 degrees. And the force being applied to this wrench is 20 newtons. So if I want to determine the magnitude of the torque, I want the magnitude of torque, which is the magnitude of R cross F. That's equal to the magnitude of R, the magnitude of F, and this time we use sine theta. Remember, the dot product used cos theta, the cross product uses sine theta. In our example, we have 0.4 times 20 times the sine of 60 degrees. So this happens to be a special angle, so let's draw out the triangle that relates to 60 degrees. This is 1, 2, square root of 3. So we end up with 8 times sine of 60, which is root 3 over 2. So our torque, so the magnitude of torque for this example is 4 root 3 joules. And you can conclude from there. So 2 focuses in this lesson. You can find the area of a parallelogram using the magnitude of the cross product, and we can apply this even further and find the area of a triangle. The cross product can also be used for calculations involving torque. Here are some questions that you can try. And good luck.